All right, so I'm going to introduce my project really quick. The problem I'm trying to solve is allowing outside users to control a web service securely without the need of authentication or exposed services. Simply put, I'm using this as a simple application of cryptocurrency as programmable money. So instead of providing authentication through credentials or exposing services through ports and port forwarding, we can use magic internet money to get things done. So you'll see here that I have a radio station running on a web service here on my local machine. And feel free to listen to my radio station from anywhere on the internet at this URL here. It pops up in random points on the internet. Now, the station itself is being fed through this local media player food bar. So what's playing on the media player gets pushed into the web service. So it's a very, very simple program that's running. So what I'm going to demonstrate is how do I control this local web service using cryptocurrency? Because the scenario I have is that my listeners may be coming onto my web service, seeing a certain album being played, and wanting to skip to the next album. But I don't really want to grant them access to my local media player unless they give me a reason to. So in this case, let's make it as simple as saying they have to pay me money in order to have access to this data, access to this feature. Now, traditionally, the way we would solve this problem is we have probably two ways to do this. The first way is finding a way to expose the buttons on the media player onto the web service, which is definitely very easy to do. We could definitely add additional functionality to the web service to have buttons to control this application. But this will basically mean that we have to have some sort of way to authenticate users. So we only want certain users to be able to see those buttons, namely the ones that are going to be paying us money. So we'll probably have to do something like a account sign up or registration in order to figure out which users are paying and which users are not. The second way to do this is, rather than creating, let's say, a user database, we would create, let's say, a fake button, like a button that would be running on the web service that doesn't necessarily tie into the media service, but the idea is that anybody can click on the button. So you don't have to have anyone register or sign up. And then the web service becomes some sort of program running behind the scenes to analyze, all the button presses. So whether or not because the buttons don't actually do anything to control the web service, we have to have some way to measure each button press to identify which one comes from a paying user and which one doesn't. In this scenario, what will probably happen is we would identify a button press that belonged to a paying user, run the procedure, and then bill that user later. So that's usually the way to solve it today. Either create some sort of like user account and sign up so we can figure out who the listeners are, or have some other intelligent way to figure out how to authenticate those users. Now, both of those scenarios require maintaining some sort of database to authenticate either the button press or the user. The only difference between those two scenarios that I've just described is that, one is we restrict the user, we expose the media player access, so we expose all the buttons, and then the crux of the development needs to come into registering specific users, so creating a user database. And the other option is we don't expose any of the features of the media player, but then we have to have some sort of way to create a database of figuring out all the button presses and identifying which ones come from paying users. Now, neither of those solutions are perfect, but that's usually how all the services are run today. And neither option actually ultimately helps me collect payments from my users at all, because again, the only way to receive payments today is P2P payments, PayPal, credit card, Venmo, things of the sort. On all those, I don't need to get into too much detail, but all those have fees, and there's some limitations if you want to receive payments from international sources. Not to mention, if I were to start collecting payment data, I also have to do some more development to secure people's credit card information and their billing information. So that's another headache that I have to build on top of this honestly worthless site. I mean, anybody can build something like this. Now, Bitcoin. Now, if I choose to use Bitcoin in this scenario, that actually kind of solves all of my scenarios. And again, implementing Bitcoin has nothing to do whether or not it's easier or harder than adding new buttons on a web service or not. The idea is that Bitcoin actually solved this issue in a very, very nice way. And the reason is because Bitcoin itself has a value, and its value is recognized by me or anybody that's part of its economy, anyone that holds a Bitcoin. And the reason why it has that value is because we know one property about Bitcoin is that it can't be duplicated, and the network itself can't be hacked. So we know that all the Bitcoins that are being sent and received are real. So I can use that property of Bitcoin, its ability to not be duplicated or not being able to hack in that way, to identify the listeners that are going to be paying for the service. Now, Bitcoin itself has its own limitations. Now, Bitcoin transactions normally take about 10 minutes because that's how the blocks propagate. And there's no way I'm going to have my I'm not going to be able to expose this feature if I have to wait 10 minutes for my listeners to send me money. So in this scenario, the listener wants to change the album. They send me a Bitcoin transaction. We wait for 10 minutes before I could possibly even think about changing it. And that doesn't quite work because, again, these songs are only 3 or 4 minutes long. By the time I receive the payment, it may have already gone to the next album, and that's not great. And on top of that, Bitcoin transactions are also not an insignificant amount of money. So it's not just a time issue, too. It does cost something. Bitcoin transactions are not only, they may be lower than credit card payments or PayPal or Venmo. They may maybe 10 or 20 cents. But again, it's not insignificant. And expecting someone to part with their precious Bitcoins in transaction fees just to control a web service radio station doesn't really quite make any sense. So Bitcoin is not necessarily perfect for this solution, but what we can do is we can use the Lightning Network to address the issues of speed and also fees. So speed and fees is something we can solve for using the Lightning Network. Now, what's really great about the Lightning Network is that it opens up the possibilities of creating micropayments instantaneously. And again, these payments can be of any amount, which is why the Lightning Network is so exciting. And we can use these micropayments to make computers do big or small things, which is what I'm going to be demonstrating here. Now, the way it works today, so on this machine, I'm also running a Lightning node, and you'll see here that it's created, I have 25 channels running, which means my node is connected to all the different Lightning nodes that are in the Lightning network. And there's this really great directory here, and you'll see there's like 7,000 nodes. I've been running my Lightning node for about 3 weeks now, and even then I've been seeing a huge increase of people using the Lightning network. So it's really exciting because last year when I saw this, it was nothing. So this has really grown from nothing. And so I'm going to show you what the Lightning network looks like. They have this really great visualizer to kind of show you what all 7,000 of those nodes are and how they're connected. The way you can look at it is each circle represents a Lightning node, and each line represents what we call a channel. Now, I don't want to get into the nitty gritty about all the components of the Lightning network, but the way that you can very simply put is that one node can send payments to another node, provided there's a route to it. So if you can draw a line between each of these dots, you can make instant payments to it. That's probably the easiest way to describe it. So what I'm going to be doing here is I'm going to have my Lightning node generate an invoice to receive payments. And I actually have a Python program running on the machine that's running, where is it? Running here. And what it does is it generates invoices from my Lightning node, and then it basically pushes it onto my web page. And what I'm going to do is I'm going to use my Lightning wallet, a Bitcoin wallet with Lightning, from my phone to send payments to it. Now, my Lightning wallet is connected to a node, so one of the circles, that can also connect to my Lightning node. So the idea is that I'm making a payment through this payment channel. So the way it works today is all I need to do is scan the QR code onto the site. And what I'm going to do is once I scan the QR code, what's cool is that in my program, once the invoice is generated, it also gives you the detail of what the invoice does. So on my invoice, it says, if you pay this invoice, we will skip to the next track. So I'm going to send 1 Satoshi to my Lightning node. And we're going to see exactly how fast this is. Again, this transaction is actually not going to my machine. It's going to the Lightning network. And the web service itself is monitoring the Lightning Network to figure out when I receive the payment. So anyways, I'm going to send this payment now, and you're going to be able to see that the media player is going to switch to the next album, and then it's going to push it to the web service. So I'm going to go pay it now. So the payment is sent and received. The media player is going to switch to the next album. So now it's playing Lauryn Hill. And then the web service is going to update, and you'll see here, now it's playing Lauryn Hill. And the invoice will update as time goes on also. So what this is supposed to demonstrate is, again, I'm able to control this media player through only cryptocurrency. I didn't have to create a user account. All it required is someone just sending me any amount of Bitcoins to this address, and it makes the web service perform an action. And that's really great. Even though this is just a really silly kind of implementation of it, because we're just doing something as simple as skipping tracks. You can think about, we can apply this Lightning payment to do something else. It could use to be controlling other services, something that's more creative, or it could be controlling devices. So that's really, really great how we can think about how micropayments can work in the world of IoT or the Internet of Things. So anyways, I hope you guys find that this was interesting. Again, I'm very excited with where the Lightning Network is going, and just using it on a day-to-day basis is just really exciting, and I had to make a video about it. So thank you again, and let me know if you have any questions.